Today I'm going to go over the number system and review some key vocabulary and then go over the formative assessment and going through the answers. So let's get going. So what you need to know for your summative. So these are some things that you need to be able to do. Convert decimals to fractions and fractions to decimals. You should be able to multiply, divide with fractions and mixed numbers. This is all with positive and negative numbers. And then also some vocabulary terms that you should know are integers, absolute value, rational numbers, commutative, associative, property of multiplication, and also the distributive property. If you are doing the optional retake for the last summative, you need to know how to add and subtract positive and negative numbers with fractions and mixed numbers. And then review, to study for that, I would review your past formative and summative, and there is also a video for that. So the vocabulary, I'm going to go ahead and just read through the vocabulary. You can write it down if you haven't written it down on a cheat sheet. So integers are the set of positive and negative whole numbers. So for example, you have -2, you can have a negative 127, you could have 0, you could have 5, and 10. So these are examples, okay, of integers. Non-examples of integers would be anything with decimals. So let's say 2.5 or -5 3/4. Or you could have a -0.05, right? Any number that has a fraction or a decimal. The more examples and non-examples that you can do, the better. An example also for an integer could also be -10 halves, right? -10 halves is just -5. The absolute value is the distance from 0 on the number line. So if I had the absolute value of -7, well, that is 7 spaces away. So it's just 7. The absolute value of a +7, well, that's still 7 away from 0. So it is 7. So if you looked on a number line, here's 0, 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Here's -7. That just means that there are 7 spaces. And then from here to here, 7 spaces. Okay? And a rational number is a number that can be written as a quotient, which is an answer of a division problem, of 2 integers. So most numbers that you know are rational numbers. So it could be what we are looked up here, this is rational, and these are all rational numbers. So whole numbers and numbers that have fractions. So you can say 3/4. You can say a -0.62 because that can be changed into -62/100, right? So, yeah. And it could also be whole numbers, so like -4, -10, 7, right? Those are some examples. Let's go to the next page. Commutative property of multiplication. Remember, that is just a rule that says that changing the order of factors will not change the product. So I can switch A times B is the same thing as B times A. Associative property of multiplication, it's a rule that states the changing and grouping of factors does not change the product. So that's just moving the parentheses. So this is A times B times C, and this is A times B times C. Then you have distributive property. We talked about distributive property where you multiply some A times B plus C. So when you're multiplying by the sum of numbers, it's the same thing as multiplying the each add-in by the add-in in the sum by the number. So you would multiply A times B and then A times C. So we're going to get into the formative assessment, and I'm going to go ahead and go through the problems for you. So if you're struggling on a certain problem, go ahead and skip to that problem. All right, so here are my examples. So how is an integer a rational number? So an integer can be written as a fraction by giving a denominator of 1. So any integer or whole number is a rational number. That's just one example. You could also say something like that every integer is a rational number because they're all whole numbers. All integers are whole numbers. You could also give an example, like if you had negative 10/5, right, is a rational number, right, because it can be written as a quotient, right, which is also equal to a whole number, right, which is negative 2. So that's just an example. And then on the number line, it should look exactly like this or pretty much like this, right? You should have all the numbers in between, and you're making the integers from 0 to 5, and the positives should be on the right. So make sure that you have your positives here, and then your negative increases to the left, okay? And some examples of numbers that are integers. You have negative 5, negative 10, 0, 14, 92. Another example would be negative 10 over 5, which is a negative 2. So remember, integers are whole numbers. And some examples of numbers that are not integers, you have negative 2.5, you got 4/5, you got a repeating decimal, you got negative 14 and 3/8. So just come up with as many as you can. So anything that has a decimal, if you put negative 10/5, it would not be a non-example because it is a whole number. Even though it doesn't look like it here, when you simplify, it is. So be careful with the numbers that you put. Make sure that they do not simplify to a whole number. All right, so for question number 2, it says write 5/12 as a decimal. So really what you need to do is go ahead and divide. So the 5 or the numerator will go under the division sign, okay? And the denominator will go on the outside. So it would be 5 and then 12 on the outside. So you should know that 5/12 is less than 1. So you should always say, well, 12 can't go into 5 or whatever that number is. If you're not, then you've done it wrong. Okay. So 12 can't go into 5. So that's 0 times. Then you add a 0. How many times does 12 go into 50? And that is 4 times. So I put the 4 above the 50. And then 12 times 4 is 48. I'm going to subtract and I get 2. I'm going to bring down a 0. Next, I'm going to go ahead and how many times does 12 go into 20? Well, that's 1 time, so I'm going to put my 1 there. 12 times 1 is 12. Subtract, I get 8. I'm going to bring down my invisible 0 and I get 80. How many times does 12 go into 80? That's 6 times. So 12 times 6 is 72. I'm going to subtract. I get 8 again. So that means that I'm going to bring down a 0. I get 80, and that would repeat, right? So that would continue. So write it as a decimal. So I get 0.416, and then that repeats. So I'd put a line over the 6. The next one is negative 3/5 as a decimal. So the negative 3 would go underneath, but I'm going to get rid of the negative for now. And then the 5 goes on the outside. So then I say, how many times does 5 go into 3? 0 times. I'm going to go ahead and put my decimal there and put a 0. Then I say, how many times does 5 go into 30? Well, 5 times 6 is 30. So then I would write 30 down below, subtract, and I get 0. And then I'm done. So if I just need to put 0.6, but remember it was a negative, so it should be a negative 0.6. Let's go on to the next problem. So looking at this question, it asks us for us to evaluate each problem. So these are our different problems. Then look at the pattern that's inside here and create it below, and then write a rule. So then we have to write a rule. So I'm going to go ahead and fill out this table, and then I'll talk about it. So let's look at this first line. So what we did was it's asking for what's the numerator or the top number. Is it positive or negative? Well, it's positive. And my denominator is positive. So 24 divided by 6, what is the answer? 4. And then I get a positive answer. If you wanted to, you could have put a 4 here, right? You could have put a negative 4, a negative 4, and then a 4, right? But those answers, oops, that's a positive 4, go here. So I'm going to go ahead and fill out the rest. If you haven't done that, make sure you do it now. All right, looking at the second one, my top number was negative. My bottom number, or my denominator, was positive. And so that gives me a negative answer. So how many negatives are there? There are 2 negatives and 1 positive. Interesting. When I had the signs here, are they the same or different? So they are different, and I got a negative answer. All right. Looking at this one, signs, are they the same or different? They're different. I see that there's a negative here. So I got difference, and they are negative. The answer is negative, right? Then on this one, both of them were negative. Okay, so the signs are the same here as positive. Let's look at this first one. The signs are the same, and it's positive. So now we need to come up with a rule stating what this is meaning, or what kind of pattern are we getting out of this. So I know that when the signs are the same, when we are what? What's the operation? Don't forget to use the operation. Dividing, the sign or the answer will be positive. And when the signs are different, my answer will be a negative answer. So I'm going to go ahead and write the rule right now. So here's my rule. When dividing the same signs, for example, positive divided by positive or a negative divided by a negative, the answer will be positive. The other rule is when dividing different signs, such as positive divided by a negative or a negative divided by a positive, the answer will be negative. You could have also used when the numerator and the denominator have the same signs, positive and positive, right? Or negative over negative, the answer will be positive. When the numerator and denominator are different signs, positive over positive, or negative over positive, the answer will be negative. So I'll go ahead and write that so you can see that. So here's the other way to write it. So when the numerator and denominator are the same signs, positive over positive or negative, the answer or the quotient will be positive. When the numerator or denominator are different signs, positive or negative, negative or positive, the answer or the quotient will be negative. So this was another way you could have done this problem. So let's look at question 5. It says, if n is a negative integer, negative 2n plus 2n equals 0, verify if this equation is true. Give an example or show your work. So I'm going to go ahead and verify if it's true by just using an example problem. So I'm going to just say if n equals, let's just say 5. But it said a negative integer, so I'm going to put a negative 5. Because it did ask for n to be a negative integer. So that means n is a negative integer, so I'm giving an example. So now I need to plug in this n equals negative 5 into the equation. So I'm going to rewrite the equation. So negative 2n plus 2n equals 0. We want to see if this is true. So we're going to plug in or substitute this. Ooh, that's a highlighter, guys. We're going to substitute this negative 5 in for the n in both places. So that negative 2 stays the same, but I'm going to, and that positive 2 stays the same. But instead of where my n is, I'm going to check, does this work? Is it still 0? Okay, so I'm going to plug in that negative 5 into here. So negative 2 times a negative 5 is a positive 10, because a negative times a negative is a positive. And then a 2 times a negative 5 is a negative 10. And I am still adding here. So I have a positive 10 plus a negative 10. And we're wondering if that equals 0. Well, I know that if I have the same amount of positives and the same amount of negatives, it will cancel each other out. Or if I'm adding the opposites, that will give me 0 equals 0. So yes, the equation is true. And I did give you an example. So I'm going to go ahead and write a little statement saying why it's true. So I just said yes, the equation is true for negative integers for n. And then you could say, see the example to the left if you wanted to. You could also describe that if I had negative 2 times n plus 2n equals 0, you can say when adding opposites, the answer will always be 0. Negative 2n is opposite of 2n. All right, let's go on to the next problem. So I need to evaluate these. So number 6, I just need to multiply. I'm actually going to use the commutative property and put the negative 2.5 on top. So a negative times a negative is a positive answer. So I want to put a positive there to remind myself. So times a negative 0.2. I'm just going to pretend like my decimals are not there. So 5 times 2 is 10. Regroup. 2 times 2 is 4. Plus this one more is 5. Don't put any decimals there. I'm going to go ahead, and I don't have anything else actually to do there. But now to decide where my decimal goes, I got to count over. So this is 1 space over, and this is 2 spaces. So 1 space, I'll put 1 space and 1 space, which is 2 spaces total. So that means I need to go over twice, and my decimal should go here. So if, so my answer should be 0.5, and it's a positive 0.5. Okay. The next one is dividing fractions. And remember, when we divide, we're actually multiplying by the reciprocal or the flip of it. Okay, so that means I'm going to automatically go ahead and flip this. So 5/4, don't forget the negative, and this would be negative 2/3. Now I can multiply straight across and then simplify, or I can simplify first. I'm going to go ahead and multiply straight across. So a negative times a negative is a positive. So 2 times 5 is 10, and 3 times 4 is 12. So I'm just multiplying the numerators together. 2 times 5, that's 10, and 3 times 4, that's 12. I can now simplify by dividing by 2. So I'm going to divide by 2 on the top and divide by 2 on the bottom. So 10 divided by 2 is 5, and 12 divided by 2 is 6. So I get 5/6 as my final answer. Next, I have a mixed number divided by a fraction. So I need to change my mixed number into an improper fraction. So the best way to do that is to go ahead and multiply the 4 times the 3, which is 12. So that tells me that there are 12 thirds in 4 wholes. Okay, so that means I have 4 wholes plus a third. I can draw it out for you if you want. 1, 2, 3, 4. And then plus I have just a third. So I'm going to go ahead and color. So it's a third. And these are all divided into thirds. Okay, and I'm trying to find out how many thirds I have. Well, I have 4 groups of 3. So that's why I'm multiplying 4 times 3. Plus I have 1 more third, right? So I go this way. 4 times 3 is 12 plus 1 more third. So I have 12 thirds plus 1 third, right, is 13 thirds. And this is negative. And you can count too. 1, 2, 3. Let me get the color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I have 13 thirds. Divided by a negative 13/24. And remember, when we divide, we're actually multiplying by the reciprocal. So I'm going to go ahead and flip. So put 24 on the top and 13 on the bottom. So the first one stays the same. So now I can multiply. I see, I don't want to multiply so big, so I am very lazy. I see this 13 on the top. If you see the same number on the top and the bottom, that means you can divide by 13 on the top and the bottom, right? And you get 1. So I can simplify first so I don't have to multiply very big. I can also simplify for over here, but I'm going to go ahead and multiply. So I have a negative 1 times 24, so that's negative 24 over 3. And I can simplify that by negative 24 divided by 3 is a negative 8. And that is my final answer. Let's go to the next question. Question number 9. Same thing. This time I'm multiplying. I need to change my mixed numbers into improper fractions. So I'm going to multiply and then add. So 3 times 7 equals 21. Plus 1 more is 22. So I have negative 22/7 times. Multiply the 2 times the 10 is 20. And then I'm going to add 3. So that's 23. That number goes on the top. And my denominator stays the same. So 10. So then I just need to multiply across. I do see that I can simplify. So I'm going to go ahead and simplify first by dividing by 2. And I can divide by 2 here. So I have a 5 and an 11. So now I can multiply 11 times 23 to get my new. So when I get my numerator, I get a actually it's negative 11 times 23. And then on my denominator, I get 7 times 5. So 11 times 23 is 253. That's going to be negative over 35. So this is a good answer. I would probably simplify this. So it'd be 253. And then you have 35. So how many times does 35 go into 25? It doesn't. So I need to see how many times does 35 go into 253. What I like to do is I go, okay, 35. And then I'm going to go ahead and multiply by 5. Because I know that 30 times 15 is 150. And that's going to give me a little bit more. I know I'm shy. It's probably 6 or 7. But I'm going to go ahead and do it this way. So 5 times 5 is 25. Because I like to multiply by 5s. And then 5 times 3 is 15. Plus 2 more. 17. So then I can just go ahead and add another 35. So this would be 5 times 6, right? Whatever I get here is 5 times 6 because I'm adding another 35. So this would be 10, that's 11, and this is 210. So I think I can do one more. So I'm going to add another 35. So this would be 5 times 7. So this would be 5, 4, and 2, 245. And that looks like to be right. So that means that 35 can go into 253 7 times. And now I can just go ahead and use this number, which is 245. And then I subtract. Oh, that's just 8. Okay. So I have 8 left over. I need to go ahead and I'm going to use this as a fraction. So it's going to be 8 over 35. And that would be my answer, except for it is negative. So I would put negative 7 and 8/35. So that's the end of the formative practice test. Please make sure that you know how to do all of these. If you can do all of them or at least some portion of them, then you will do well on the test. All right, good luck on your summative.